Okay, question number 2. Let's read this question. Let's highlight what is given. A man 6 feet tall. So we know this man's height is going to be 6 feet tall. Walks at a rate of 5 feet per second away from light that's 15 feet above the ground. At what rate is the tip of his shadow moving when he is 10 feet from the light, from the base of the light? Okay, let's list what is given, okay, and let's understand what is asked. At what rate is the tip of his shadow is moving? This is the question. Okay, so let's mark this distance from here to there. Okay, I think from here to here. Yeah, let's mark this as y, the distance of the shadow's tip from the base of this light pole. Okay, what is asked? We need to find out the rate of change of the tip of the shadow, which is the rate of change of y, which is dy over with respect to time. Yeah, as time changing, we gotta find the rate of change of the tip. Let's list what is given. What do we know? We know that man 6 feet tall. Okay, this height here is gonna be, his height is gonna be 6 feet. Okay, man height. Uh, let's rewrite it in a different way. Let's say given height of the man equals to 6. And what else do we have? We have here 15 feet, which is the height of this light pole, which is gonna be 15 feet. Okay, height of light equals to 15 feet. We have one more thing given. He is walking at a rate of 5 feet per second, which means the distance from this light pole to this man, let's say this is gonna be x. That x is changing, okay, the change of x with respect to time, okay, x over t. Remember, x over t is gonna give you the velocity. Yeah, similarly for the velocity we use differentiation, the rate of change of the disposition of this man, where it is gonna be 5 feet per second. 5 feet per second. Okay, now when we have w, when is this gonna happen? When he is 10 feet from the base, which means when x is gonna be 10. Okay, we gotta think this carefully. Okay, we gotta calculate this one for x equals to 10, at x equals to 10. Okay, let's try to understand this. We have here, don't have a line here. Okay, we have here a little triangle and a bigger triangle. Okay, they are what you have learned from geometry classes. They are similar triangles, so we are going to use the property of the similar triangles. Okay, so let's try to understand how to deal with this question with the similar triangles. Okay, let's simplify this view. Okay, and we have here this this distance is the height of this person, and from this side of this triangle is the height of the light pole. From here to here is this man's distance to the base of the light pole, and this side is the distance of the tip of the shadow to the base of the light pole. Okay, so right now we can remove this picture. Okay, we have simple, just two triangles. They are similar to each other. Okay, so let's use the properties of the similarities. Man's height is given. Height of the man is 6 feet. So this distance is 6 feet. Height of the light is 15. So this side of the triangle is 15. What is we have here is the small triangle is similar to the bigger triangle. Okay, let's write down the similarity properties. Okay, similarity of this similarity proportions. Okay, let's identify this distance. The total is y. Subtract x, so you will get y minus x. Okay, if you think this, if let's say this is alpha, and let's try to understand tangent alpha for the small triangle. You know what? I have right angle here. Okay, so tangent alpha, you don't have to calculate tangent alpha. You are gonna see the relationship is 6 over y minus x. 6 over y minus x, which is going to be equal to, tangent alpha is going to be the same here as 15 over y. So you don't have to really know about the tangent alpha now. Okay, so let's continue with this proportion. Cross multiply 6 times y is going to equal to 15 times y minus x. Be careful, you need to use parentheses and distribute 15 over parentheses in the next step. So you'll get, this part is simple math, 15y minus 15x. Move like terms to one side, so 15x is going to be here. Let's collect y's on the other side of this equality sign. Okay, so we have at the right side 9y. Okay, so what we are trying to do is we are trying to find out dy over dt, given the fact that dx over dt is 5 feet per second. Let's try to take both sides d over dt, d over dt. Here you have 15 times dx over dt equals to 9 times dy over dt. Okay, and this is the part that we are trying to find out. Same thing occurred here. Okay, so 9 times, what is 15 times dx over dt? Do you know dx over dt? Sure, you know. Dx over dt is given here, which is 5 feet per second. This was the displacement, this was the man's speed at that given time. The man has the rate of change with his distance, okay, in this one. So let's plug this everything in. So 15 times 5 is going to be equal to 9 times dy over dt. So you can solve the rest of the question. The rest of the question is going to be dy over dt equals to 15 times 5 over 9. You can simplify, you'll get the answer. Thank you for watching.